Grade 5 pupils, here's our first video on the addition formula, and in this particular video we're looking at sine of A plus or minus B. Okay, these formulas are used to simplify or evaluate trig expressions. Okay, two formulas. We have sine A plus B, where we have the consistency of a plus, and we have sine A minus B when we have the consistency of a minus. Okay, how this will show in your formula sheet is we have the symbol plus or minus and plus or minus. Okay, as we said, we look to simplify or evaluate the trig expressions. In this first example, expand and simplify sine of x plus 30. So sine of x plus 30 degrees is equal to, we look at our two formulas, and it's going to be this first formula. And if we have an A and a B value, we have sine x cos 30 plus, so the consistency in the plus in the sine x plus 30 and the plus in the expansion, and we have cos x sine 30. Okay, what's absolutely vital in these questions is their exact values. Okay, either you're knowing the table well or be able to work them out using the triangles. Okay, I wouldn't write out the table of the triangles, I would just go through these as the values are known. Okay, so sine x is what it is, and cos 30 is root 3 over 2. So that's the two of those multiplied, and then we're going to add up cos x multiplied by sine 30, which is a half. So those two values are straight from our exact values. And then that's going to simplify as root 3 over 2 sine x plus a half cos x. And that is our expression. Okay, a very common use is to be able to work out values which do not fall within our usual exact values. However, what you're always considering is the exact values that we know. So consider 30, 45 and 60 degrees. Okay, what we mean by that is if I'm looking to try and find sine of 105 degrees without a calculator using exact values, then I can get a link. And my link is going to be using 45 and 60. Okay, I think we're all in agreement that 105 is equal to 45 plus 60. So what I've got is I've got an equivalent expression, and that expression can again use my expansion. Okay, my expansion states when I have an A and a B value, I have sine 45 cos 60 plus in expansion there, plus cos 45 sine 60. So I've expanded using my values, and now I have four different trig exact values to calculate. So sine 45 is 1 over root 2, cos 60 is a half, cos 45 is again 1 over root 2, and sine 60 is root 3 over 2. Okay, I will always have consistency with my denominator, root 2 and 2 multiplied, and then add root 2 and 2. So there's always that consistency. Multiply top, 1 over 2 root 2. Multiply top again, root 3 over 2 root 2. And then as a single fraction, because I've got the same denominator, I have my evaluated expression. So that's an exact value for sine of 105 degrees. Okay, an exact value of this time sine of pi over 12. So what I'm going to do in this case, I'm actually just going to get a value for pi over 12. Okay, pi over 12, I'm going to multiply by 1, I'm not changing its size. Pi over 12 multiplied by 108 over pi. They'll both cancel. So 180 split 12 ways is equal to 15 degrees. Okay, so what I'm saying is I want the sine of pi over 12, which is exactly the same. Sine is 15. Which, again, I'm going to look at my exact values. How can I get 30, 45 and 60? I actually get two options, 45 minus 30 or 60 minus 45. Absolutely, either would be absolutely fine. I'm going to go 60 minus 45. Okay, I'm now ready for my expansion. I have sine 60 cos 45 minus cos 60 sine 45, straight from my expansion. Root 3 over 2 times by 1 over root 2, subtract a half times by 1 over root 2. Again, consistent denominators as always, root 3, 2 root 2, 1 over 2 root 2, and then as a single fraction, root 3 minus 1, 2 root 2. And that is my exact value of sine pi over 12. Okay, for some questions there, show my homework for some specific details from your teacher. Thank you.